is Salah Sukkarieh. I'm a Professor of Robotics Intelligent Systems at the University of Sydney. Thank you to organisers for granting me this honour of being able to present to this group. So it's a really, really great initiative, and looking forward to presenting the work that we've been doing at the ACFR. The presentation focuses on field robotics, in particular robotics work that we've done to deal with the outdoor vegetable industry. So we have to build robots that have to work 24 hours, 7 days a week in all different weather conditions in very either semi-structured or unstructured environments. This is a team effort. It's there's a lot of people that have been working on this activity at the ACFR over many years. Backgrounds in mechatronics, software engineering, electrical physics, mathematics, optimization theory, and the list goes on. We've also been funded by a number of large organisations in Australia to support the activity. You can see them on the bottom there. In Australia, we have what we call a levy funding system, and that's where the farmers, when they sell their goods on the market, a certain percentage will go through to the government, which will then be used in addition with government funding to fund R&D activity back to that particular industry. So we have horticulture levy funds, vegetable levy funds, meat and livestock levy funds, and so forth. So the focus is really around automation and robotics and intelligence, and how we can bring that on farm and build a much more sustainable agriculture industry, something where we can produce more given less land. But automation and robotics hasn't been something that's just new. This is a postcard from 1900 in the city of Paris, where the Parisians were asked what does the future of what do they think will happen by the year 2000. And this is one of those postcards that was developed, which was the ability to kind of help the farmer and make the farming life easier. And so that's been around for a long time and still exists for today. It's a hard problem, and over the years what we've seen is that in order to maximize productivity, we've gone for larger, bigger tractors. We've had to use more chemicals in order to be able to supply the food that's necessary, and at the same time we've also commoditized food. So we've gone down to the single monocultures of food that are out there in the environment. But there are additional factors, especially in Australia, that I wanted to kind of touch on. The age of the growers in Australia is getting older for those that are working on farms. So you'll see that here, that on the average, farmers are around somewhere between 55 to 65 years old that are working in the agriculture industry, compared to what the total workforce might look like. And if you start to see that compared to the kind of the executive levels, you also see that the growers are much more on the older age. And so because farmers are getting older, it's getting harder to work on farm. Furthermore, and I haven't shown it here, but the labour supply chain is a lot harder for the agriculture industry in Australia. Less people want to work on farms. And on top of all that, the Australian labour cost is one of the highest in the world. Now this fluctuates. Australia fluctuates between 1 and 3 all the time, but we have a certain minimum standards in terms of the minimum wage cost, and that has a knock-on effect, especially as we go into aspects around superannuation. So we have an ageing workforce. We have a labour workforce that's hard to get because people don't want to work on farms. And if you can find workers, the cost of hiring them is quite expensive. And on top of that, Australia is quite a large place, and it has it covers a wide expanse, high latitudes. A range of latitudes, which means that there are different cropping conditions as you work through. So that kind of gives you a picture, and if you overlay that with agriculture, you kind of see where most of the cropping activity and the meat and livestock activity happens. And on the right there, it also gives you a touch of the breakdown of the different industries. So hopefully that gives you a picture of why field robotics in Australian agriculture anyway is quite an important element as we look across the whole spectrum. In the horticulture industry, it's quite important, and especially in the vegetable industry, because it has one of the highest labour costs across that, because we're dealing with fresh food, and we're dealing with production that happens over somewhere between 2 to 3 month cycle continuously through the year. And so because of that, we get a high labour cost within the vegetable industry in particular. And so we've been funded over the last 15 years, 10 to 15 years, looking at robotic solutions. Now, this is one of our first robots that we built, which was Ladybird. We received enough funding from the vegetable industry to re-look at what it means to build a ground robot for the vegetable industry, instead of, for example, taking a tractor and automating a tractor. So we could go back to basic bread principles, understand training concepts around drive modules, drive trains, diesel versus electric, solar energy, the use of that, how would you reconfigure a platform, etc. This is one of the first platforms that we built, which was Ladybird. Ladybird allowed us to kind of change the wingspan, which meant that we could go for different height crops. We could also then come along and change the width for different row crops, and we also had a little system in between that allowed us to kind of go down on a hyper and low for different ground undulation. So that gave us a very flexible robot that could come along and work on different vegetable crop farms, which was necessary because when you're dealing with outdoor vegetable farms, you don't have a standardized row width, bed height, and crops that you can work with. So we could put a whole bunch of different sensors on board. You can see there in the top right-hand corner, thermal sensors, stereo camera, laser sensors, GPS inertial, and it ended up being a really novel phenotyping platform that could fit into a back of a trailer and that we could take it out from there. And this is just showing you some of the capabilities of the platform. It's an omnidirectional platform, so it was a four-wheel drive, four-wheel steel electric bot, which allowed us to navigate over very small headlands. So that's the brown bit that you see there. Sometimes they can get very small, so it allowed us to navigate across those quite easily and up and down rows. And the bot can then come along and just collect large amounts of data, and we can use multispectral, hyperspectral sensors and start to collect all that information. And that gave us a unique platform to work with and to kind of collect that information and classify vegetation and build up. And this was a few years back. So the vegetable industry enjoyed that as a platform, and they wanted us to take it to that next level. And so they funded us further to look at the technology maturation. And so we had two programs, and the names are there: Veggie 15003 and Veggie 15059. And basically, Ladybird was a platform that allowed us to do sensor research and data analytics, automated decision support systems. But then once we were confident with that, then lead on to the next level, where we could actually start to put it on another platform that would work on operational farms and learn a lot more while dealing with the farmers directly. And that platform, that second platform that you see is called Ripper. And so when we were happy with that, then you actually matured that technology. So you went from a TRL 0 all the way down to that number 9, where you could then operationalize or commercialize that technology either through specific trials or spinning it out, licensing it, dealing with OEMs, whatever it might be from there. Ripper itself had to do a couple of tasks. It had to do decision support systems as well as crop interaction systems. In the decision support systems, we wanted to be able to do things like individual crop mapping, soil mapping, and look at yield estimation. And in the crop interaction, we wanted to do things such as precision herbicides application, mechanical weeding, etc. As we went through. So the whole idea was Ladybird would give us the research platform. Ripper would allow us to do an operational platform, almost like a pre-commercial prototype, and then we would learn from that, and that could then be used to kind of navigate out into the real world and interaction with the farmers and OEMs. So we did a number of controlled experiments. That was the whole objective. So in particular, we had a university farm where we could take Ripper. You could see there a typical experiment on the right where we would, in the dark blue, add more water on a couple of rows, in the dark brown, less water on a couple of rows, and then within that, less fertilizer, more fertilizer, etc. And so you could actually start to do some very controlled experiments, take out the phenotyping system, and for example, what you see here is a typical result. The bot would go up and down collecting information, and you would have people walk straight behind that bot all the time, collecting and sampling data, and then taking it back to the lab. And so that way you had this controlled experiment where you take this lab data information and compare that to what was happening with the data that was collected from Ladybird. And then you could start to come along and do some sort of, you saw there a color checker, and the bot would go through and you could start to detect certain qualities, certain features about the plants, whether they were plants or weeds, and do that classic classification. But on top of all that, you could then come along and start looking at multispectral data and start to look at some distinct bands. As you can see there, extra water, less fertilizer, or nitrogen in that case, extra water, more fertilizer, and you could see these bands coming through across the different indices on the left, and those indices on the left are typical indices that the agriculture industry were using. But more importantly, we could then come along and apply machine learning techniques on top to see whether any of those indices were better than others, depending on to give us things such as yield estimation, or whether there were new indices that we could develop out of the machine learning solutions as well. And that gave us a lot of information, and then we could come along and start doing some quite accurate yield prediction and build up some growth models from that. So if you could come along and go week 1, week 2, week 3 and start to do those estimates along with the multispectral information, use machine learning techniques, then you could come along and predict forward at a time. So what you'll see down below, what would happen at week 7 if I added more fertilizer, a lot more fertilizer, or do nothing at all, and what would the prediction were from there. And so that gave us this yield prediction scenario, which was valuable for the farmers to look at. Now, it didn't capture weather events, and that's a major aspect for large outdoor field environments, but it allowed us to look at if weather was consistent in terms of the prediction, then what do we expect the yield results to look like. So armed with that, you could actually start to build some models, and then you could start doing some field trials with this prototype ripper that will allow us to go onto farms, engage with the growers, and start to understand from the growers what worked and what didn't work. On the right there, you'll see some locations across Australia, especially in the southeast of Australia. So between the lowest part and the highest part, we're talking probably about 3,000 kilometres of vertical distance. So it was a very extensive activity, but it did allow us to get to the farmers and be able to communicate with the farmers precisely what was going on. So this was an example of pushing the boundaries on the bot and being able to do things like, in this case here, a complete, well, as close as we can to a 24-hour trial starting early in the morning, and the robot was just purely on electrical engineering, but at the same time it was harnessing solar energy. It was going up and down the rows, and it would just go through all through the day and all through the night. And then as the night kicked in, I'll just jump it a little bit forward. As the night would kick in, sorry, I'll just start here. As the night would kick in, it would go through up and down, and then partly stop in the middle of the night about 3 a.m. or something. In this particular case, got to low power mode, and then the next day when the solar came up again, it would recharge and start all over again. And that was the whole objective, was to have this continuous bot that was continuously present out there in the field all the time. So what was the robot doing? It was collecting data in real time, doing machine learning and being able to assess crops in real time, and that was key to the project objectives. So as the robot was going down, can I detect individual plants? Can I look at yield estimation scenarios as well, and be able to kind of estimate what the yield was, and maybe even the projected yield? And that's what this is doing now, is looking at almost like in a 3D photogrammetry application. If I could detect weeds, can I mechanically remove the weeds and scratch them out in any way? In that particular case, is what this is showing you here, is just the weeder being able to detect where the weeds are and mechanically remove the weeds. Also, if I could detect individual plants, could I then come along and the reason why we mechanical weed is reduce herbicide use, is then also detecting individual plants and spraying the right amount of, whether it's herbicide or fertilizer, on that individual plant, so that you can reduce crop variability and maximize yield in some way. And also water sampling, so you could kind of be able to look at detecting and collecting the amount of water that might be located at any particular point on the farm, and sampling through that. So basically what you got was this digital agronomist. You could do other things as well. So for example, in this case here, it was detecting foreign objects, and this is just a vacuum cleaner that we connected up to the robot, and when the robot would detect a particular object, it would then come along and just suck up that object in a particular form, and be able to take it. In this particular case, it was looking for those blue foreign objects and sucking up those foreign objects. So that allowed us to build up this almost like a platform that could operate almost 24 hours, do tasks on farm, as well as mechanically remove weeds, spray, remove foreign objects, but also the farmer could come along now and start to look at the history of any particular plant, click on a particular point and location, and be able to understand the history of the plant if they wanted to. But usually what you'd like to be able to do is remove as much information from the farmer, because they get information overload, and be able to provide them with the right amount of information. But this still gave them a good tool to work with. We also worked on smaller platforms, because the platform that I showed you before is a nice platform for many of the larger growers, but you also have small horticulture growers. This is a robot that we called the die wheel, which was just a 2-wheeled robot that you could easily put into the back of a vehicle, connect it up together, start doing some sampling as you're going up and down the rows, and start collecting some information about the plants. But you could also come along and add another element to it and we used a mobile phone in this case here, using the camera on the mobile phone, be able to detect individual plants, do some sort of yield estimation, have the mobile phone talk to implements, and be able to spray, for example, or seed as well. We were fortunate enough to take that platform and get some funding from the government, and they asked us to beef it up a little bit, but look at smallholder farmers, not just in Australia, but also around the world. Could we go to, say, a developing country or a country that's trying to boost up its agriculture economy, and see whether robotics would be useful? And we received funding to go to both the Pacific Islands. We went to Indonesia, Fiji, and Samoa, and we demonstrated a bot that could go to the back of the ute and back of a vehicle like this, be able to winch down, start, and off you go up and down the rows and start collecting information. And the unique thing that we found was that it didn't matter which country you're in. So even in Fiji or Samoa and Indonesia, labor costs were still high, labor availability was still a problem. So it showed that the concept of robotics and intelligence systems being on farm wherever you are in the horticulture industry around the world was an important element. And this is just showing you some of the work that we did in this particular case was in Fiji, of detecting and doing some yield estimation. So that gave you a wrap up of the work that we're doing. Just recently, we spun out the technology. We formed a company called Ageris, and Ageris now really focuses on building a commercial production platform for the vegetable industry. Solar electric. This one gives us up to about 15 hours. We can add different tools on the bottom. It's remote control as well as GPS auto guidance, can follow rows, can do auto turns, very much similar to what I showed you before, but now it's coming down on a scale type of level to be able to look at commercial applications. And the company now, Ageris, the spin out has been around for a year, and it's been focusing on building that commercial prototype, and is now just currently exploring and working in different farms across Australia. So that's the end of my talk. I thank you for your time. Hopefully that's given you a picture of what's been happening in Australia, at least in the field robotics scenario, and I hope that gives you an area. Where we're continuously pushing on the R&D is how you still do real-time machine learning and different tools that might be relevant on horticulture farms, and being able to apply them in that context. Thank you.